Welcome to this video on the 8086 microprocessor. The 80806 is the one of the most significant microprocessor in computing history, released by Intel in 1978. It is the way for the modern x86 architecture that powers many computers today. In this video, we will explore the architecture, features, and significance of the 8086 microprocessor. A microprocessor is a central processing unit integrated into a single chip. It is the core component of the computer system that performs calculations, executes instructions, and processes data. Microprocessors are designed to handle a wide range of tasks and are typically used in personal computers, servers, and various electronic devices. Some of the key features of microprocessors are: it is a single chip. All essential CPU functions are integrated into one chip, minimizing size and power consumption. It is capable of executing complex instruction sets, making them suitable for general purpose computing tasks. A microcontroller is essentially a microprocessor that, along with its associated supports circuitry, memory, and peripheral input-output components. It is implemented on a single chip. The integration makes microcontrollers ideal for embedded systems where compact size and efficiency are crucial. Some of the key features of microcontrollers are: it combines the CPU, memory, and input and output ports on a chip, reducing the overall system size and complexity. It is designed for specific controlled applications such as household appliances, automotive systems, and industrial machines. Example: AVR microcontroller. In our case study, we focus on AVR microcontroller family. AVR microcontrollers are popular due to their ease of use, robust performance, and wide availability. Microprocessor can be categorized based on several key characteristics. Word size. The word size indicates the amount of data a microprocessor can process at one time. The 8-bit processor handles 8 bits of data suitable for basic application. 16-bit processor process 16-bit of data suitable for more complex tasks. 32-bit processor handle 32 bits of data, support larger memory and more advanced function. And 64-bit processor process 64 bits of data, ideal for high performance tasks and a large data set. Instruction set structure. There are two types, RISC and CISC. The first one, a reduced instruction set computer, uses a small set of simple instructions, making it efficient and fast, often executing instruction in a single clock cycle. Second one, complex instruction set computer. It contains a larger set of complex instructions that can perform multiple operations but may take longer to execute. Based on the functions, microprocessors serve different functions which include general purpose microprocessor designed for a variety of tasks from personal computing to embedded system. Special purpose microprocessor tailored for specific applications such as image processing, floating point calculations. Image processing optimized for handling images in cameras and video editing. In the case of floating point calculations, it is designed for complex mathematical operation in scientific tasks. Intel 8086 microprocessor. The Intel 8086 microprocessor, designed by Intel in 1976, is a 16-bit microprocessor with the following features. It has 20 address lines, allowing it to access up to 1 MB of memory. It features 16 data lines, enabling it to transfer data in 16-bit chunks The 8086 has a powerful instruction set that simplifies the operations like multiplications and divisions. 8086 supports two modes of operation: maximum mode, minimum mode. Maximum mode designed for system with multiple processor, multiprocessing environments. Minimum mode intended for system with a single processor, single task environments. Features of 8086: the 8086 microprocessor includes an instruction queue that can store up to 6 instruction bytes, enhancing its ability to fetch instruction efficiently. First 16-bit processor, it is recognized as the first 16-bit microprocessor. 16-bit ALU contains a 16-bit arithmetic logic unit for processing data. 16-bit registers features 16-bit register for storing data. Internal and external data buses. It has a 16-bit internal data bus and a 16-bit external data bus for data transfer. Pipelining: the 8086 uses two stages of pipelining, which helps improve performance. The two stages are fetch stage and execute stage. In fetch stage, pre-fetches up to 16 bytes of instruction and store them in the instruction queue. Execute stage executes the instruction stored in the queue. The 8086 microprocessor is a 16-bit processor with two main parts: bus interface units, and the second one is execution unit. Let us see one by one. The first interface units handles the communication with the memory and input-output devices. It fetches instruction from memory, calculates addresses, and handles the data transfer. Instruction queue: it stores up to 6 instructions in advance to speed up processing. Segment registers: these help manage memory, dividing it into sections or segments. Code segments holds the address where the program's instructions are stored. Data segment store data for the program. Stack segment manages the stack for temporary storage. Extra segment and additional data segment. In the execution unit, the execution unit handles executing instructions. It gets instruction from the PIU, decodes them, and then performs the record operation. Some of the key features are general purpose registers. These are used for various calculation and temporary data storage. Some important ones are accumulator register, often used in arithmetic operation; base register, used for addressing; counter register, often used in loops; data register, often used in multiplication or division; control flags. These flags indicate the status of the operation, like zero, carry, or overflow. The memory in the Intel 8086 microprocessor is divided into several sections known as segments. Each segment serves a specific purpose, enhancing the organization and management of data and instruction. Code segment: this segment contains the executable program code. It stores the instructions that the CPU will execute. The second one, data segment. The data segment is used to store initialized and uninitialized data. This includes variables and constants used by the program. Extra segment primarily utilized for string operations. This segment provides additional storage for data and help manage larger data sets that may not fit in the data segment. Stack segment. The stack segment is employed for stack operations such as pushing and popping data. It manages functions calls, local variables, and return addresses, facilitating efficient function execution and memory management. The Intel 8086 microprocessor features several general-purpose registers that are versatile and used for various operations. These registers can store temporary data, serve as operands for arithmetic and logical operations, and facilitate memory addressing. Here is a breakdown of the key general-purpose registers. The first one is accumulator. The size 16 bits. The accumulator register is primarily used for arithmetic operation and logic calculation. It can store the results of the calculation and is often used as the default register for operation requiring an accumulator. AH, the high byte of the accumulator registers. AL, the low byte 8 bits of the AX register. Base register 16 bits can also operate as two 8-bit registers PH and BL. The base register is utilized for base addressing in memory. It can hold data or addresses, making it essential for data manipulation. BH, the high byte of base register. BL is the low byte of the base register. Counter register, it is 16 bits, can also operate as two 8-bit registers CH and CL. The counter register is often used for loop counters and string operations. It can hold the count of iteration in loops and provides control for various instructions, especially in string processing. Data register 16 bits can also operate as two 8-bit registers DH and DL. The data register is commonly used in input-output operations, multiplications or division tasks. It can hold extra data during arithmetic operations, especially when the results exceed the size of the accumulator register. In addition to the general-purpose register, the Intel 8086 microprocessor includes specialized registers known as pointers and index registers. These registers play a crucial role in memory addressing, enabling effective data manipulation and access. Here is an overview of these registers. Stack pointer. Pointer registers are used to hold addresses in memory specifically for the stack and code segment. Stack pointer 16 bits. The stack pointer register points to the top of the stack in the stack segment. It is automatically updated during the push and pop operation. It helps manage the call stack for function calls, local variables, and return addresses. Base pointer 16 bits. The base pointer is primarily used to access parameters and local variables in the stack frame during procedure calls. It provides a base address for referencing data and the stack, allowing easier access to data relative to the current stack frame. Index registers. Index registers are used for indexed addressing modes, facilitating array and data structure manipulation. Source index register 16 bits. This Source index register is often used as source pointer in string operations. It holds the offset address of the source operand, enabling efficient data processing in memory. Destination index register 16 bits. The destination index register serves as a destination pointer in string operation. It holds the offset address of the destination operand, allowing the microprocessor to move data between memory locations efficiently. Instruction pointer is a vital register in the Intel 8086 microprocessor architecture. Here are the key features of the instruction pointer register. 16-bit register. The instruction point register holds the address of the next instruction to be executed. This allows the CPU to keep track of the flow of execution in a program. It serves as a offset for the code segment register, enabling the processor to calculate the effective address of the next instruction. The actual physical address for instruction fetching is obtained by combining these CS and IP register. Flag or status register is a critical component of the Intel 8086 microprocessor. It contains several individual flags that provide information about the status of the processor and the results of operations. The heap features of flag or status register. It contains 9 flag bits, with 7 of them being status flags and 2 being control flags. These flags tell about the status of the processor after any arithmetical or logical operation is performed. If the flag value is 1, the flag is set, and if it is 0, it is said to be reset.